Well, good morning, everyone. My name is Richard Evans. I'm the Information Systems Manager at the NASA Glenn Armstrong Test Facility in Sandusky, Ohio. And I would like to talk to you today about how we do risk management at Armstrong Test Facility using MediaWiki, and I'm going to use the phrase plus, and I'll explain that in just a moment.
Hey, Rich, step one step this direction.
Okay.
Don't go down.
We need to put some tape on the floor. So I want to make sure. One of my concerns as I was putting these charts together was that it is not my goal to teach you guys. This is not a training session for NASA risk processes. So what I want to do, though, is I want to communicate that that NASA has a very elaborate process, agency-wide, a very well-documented specification for how to manage and handle risk. It's a very important part of NASA's overall mission strategy for mission success. So those of you that know me know that I have talked at great length about how MediaWiki, with the right set of third-party extensions, the functionality can be extended, and you can use MediaWiki not only in its encyclopedic function, but also in its electronic workflow capabilities. We add that, and so this is really just an opportunity to show you some detail about how we took a very important process within our organization and we fulfill that process electronically using MediaWiki Plus. So the big takeaway here is, if this is the one message I have here, is that MediaWiki has what it takes to do risk management at NASA, and that is no small thing. As far as an outline goes, I'm going to try to introduce the idea of where I come from, what risk is, why we do it. We're going to talk about our process just a little bit. There's a lot of eye charts. I'm going to try to skim through them fast. Again, I think these charts will be made available online publicly, so don't worry too much if you can't see all the detail. And I keep using the phrase MediaWiki Plus because in my world, when I say MediaWiki, people think immediately of core MediaWiki, that you would just go to MediaWiki.org and download the base software. And what we're doing is what I call MediaWiki Plus. And again, we've identified a number of key third-party extensions that extend the functionality and allow us to do these enterprise workflow applications. So a little bit about my world. So NASA is in many places throughout the United States. Specifically, this is just a map that shows all the different places where you can visit a NASA center. We're in north central Ohio. We're at a place called the Armstrong Test Facility in Sandusky, Ohio. We operate some of the world's largest space environment test facilities. I've identified just a few of them on the map. And at the end of the day, what we are is we provide space environment test services to our NASA customers and our commercial customers. So we don't test full-scale launch systems, but usually at the top of every rocket that's on the launch pad, at the very top is some payload that somebody's trying to put into space. And so on the left, I've got an example of the Artemis launch system with the Orion capsule on top, and we do the ground testing of the Orion capsule. And on the right, you can see the SpaceX Falcon 9 launch system with the Dragon capsule on the top. And we do testing. So basically, if you're building something and you want it to work in space and you don't want to wait, you want to find out for sure that it works before you launch it, you come to a place like our facilities. As far as risk management goes at an organizational level, everything that I'm going to tell you about risk-wise is defined in a high-level NASA policy document on risk management. And then there's a very detailed handbook. Both of these documents are online. I've linked them both at the bottom. If you are interested and want to become super savvy on NASA's risk management policies and methods, all the information that you need is documented in these public documents. Okay, so point of entry. On the left, we see a typical organizational hierarchy pyramid. NASA is an organization, and so we have top-level organizations and mid-level all the way down to small branch-level organizations. And at the very top, you have agency strategic goals and congressional funding, and the money flows from top to bottom, and the services and deliverables are being provided from the bottom up, shown on the right-hand side. Now, the deliverables, if in a world where nothing goes wrong, right, we don't have to worry about risk because everything just works. But nobody lives in that world, and so risk is a core part of any project trying to deliver to market, to any stakeholder, or anyone that you're trying to make good on a promise to or requirement. There's always some risk that you have to manage. So there's a couple of high-level statements about what risk is. You can choose the one that you like the most. I like to focus on the fact that it's about documenting and communicating, because oftentimes, when we're on the hook to do something and we have a deadline and we have a budget, we're trying to manage those things as a project, and documenting the decisions that we make and communicating the risk is an important part of maintaining ultimately the success of the overall project. As far as why we do risk, well, there's a couple of reasons I could give you, right? Starting at the top, it's agency and center level policy requirements. We have to, but our customers expect it. There's a lot of moving parts in a large, complex program, and risk management has to be done across all the different stakeholders. You could go down the list, and at the end of the day, right, it's all of the above is why we do risk. It's how we get more resources. This is one of my favorite ones to point out. It used to be that if you had, if there was a budget, you could advocate for what the best way to use that budget was from a value standpoint. The agency is now moving to a more risk-driven model for deciding how to spend limited resources. And so from a top-down perspective, what people are most interested in is how can we mitigate the most risk for the least, how do we best use the money to mitigate risk, maximizing our mission success. On the left, we have this, it's called the acquirer-provider model. And so we're going to keep that theme going forward. And just to show you how this shows up in our world, the people that develop the launch system is one group, and the launch system is a deliverable. The people that develop the payloads or the spacecraft that are actually going into orbit, the Orion crew module, the Dragon capsule, there are different teams. So the people, even though it's the same, even though NASA's developing everything on the left and SpaceX is developing everything on the right, within those organizations you have different groups with different deliverables. And then you have the Armstrong Test Facility in the middle, and our job is to provide these test capabilities. And so if there's a launch schedule and being able to verify that the spacecraft passes all of the tests is one of the prerequisites to being able to successfully launch, then any problems that happen in the testing phase will then ultimately impact the launch schedule. So there's multiple different groups here, and the point is that risk is happening across all the levels. Now, this is an eye chart. The purpose of this chart is to show that NASA has three main dimensions of technical project management. This first section inside the blue oval, on the left-hand side, you have your system design process. And on the right-hand side, we have our product realization process. And in the middle is the technical management process. And if you look at all those items, what I've put a red star on, number 13, is technical risk management. So risk management is just one of almost 20 different areas that are very well defined in the NASA systems engineering process. And you can also see on the far right that risk is accumulating. So we're receiving risk from the components that we are dependent on, and we're integrating their risks with the way that we're providing our services, and all that risk, and that's what that red line on the right is showing, that risk is all rolling up as it moves its way up the organizational hierarchy. Now, that technical risk management has a name, and we call it continuous risk management, or CRM. And so that you can see the CRM, the simplified process diagram is shown as a circle. We're going to talk about those 5 phases. What's important here is to know that at each level of the organization, they are each independently doing continuous risk management. And the risks at one level are feeding into the higher levels. Now, the agency has specified the minimum requirements that all continuous risk management processes must fulfill. What they haven't done is specified exactly what tools and local implementations of those procedural requirements. So that gives us the opportunity at the Armstrong level to decide how we're going to fulfill the CRM process requirements. This chart is just basically showing 3 different ways to see the same thing. In the top left, the little circle, you have the simplest way of seeing the CRM process. Underneath the circle is like a 5-stage waterfall process where each of the stages is identified. And then if you really want to get interested, it kind of unpacks a little bit where you have multiple analysis phases depending on whether you're doing strategic or tactical mitigation planning. But all of these have decision processes, and they all have formal inputs and formal outputs. NASA is an ISO certified organization, and that means that all of our processes need to be ISO business processes as well. So for that, I'm going to do a quick overview of what ISO means. For those that haven't heard the term, ISO is International Organization for Standardization. It's a non-governmental, independent standards development organization. Their main product is a set of specifications for quality business processes called ISO 9000. Now, ISO 9000 is extremely generic. And so, if you're in the space industry, your way of fulfilling ISO 9000 is going to be very different than if you're in the automotive industry or any other industry. So the different industries will come together and create sort of a standard way that industry fulfills ISO 9000. And for NASA and the entire aerospace industry, it's called AS 9100. And so our organization is following AS 9100 process development. And what you can see is we have our policy documents feeding in the process, defining the process in the top left, the low-level work instructions, giving detailed instructions as to how the tasks are completed, and all of that goes into a typical actor swim lane business process diagram that shows different roles and different departments exchanging information and producing artifacts at different points. All of this, and this is the big takeaway from the ISO piece, is that all of this we're required to have evidence that we can show anyone who investigates or audits our processes. We need to be able to show that we're doing what we say we do. And so what that means is that we're looking for some kind of a way of implementing the risk management process in a way that is safe, effective, and reliable in doing what it's supposed to do, but also has traceability and generates the necessary artifacts and allows us to find who did what, when, and where is that information now, and how did it change. And that is one of the things that MediaWiki Core does beautifully right out of the box. Now, those that have seen some of my past talks know that we are heavily invested in Semantic MediaWiki, which is a third-party extension that allows you to, a couple of fun facts is Semantic MediaWiki allows you to store data directly into pages. It allows you to write queries in other pages that finds all the data that you've stored in the other pages. And if you take those 2 fun facts together, you realize that this allows you, this is the fundamental method of basically building a database application. So anything that you might have done in traditional relational databases, you can immediately migrate and implement them in MediaWiki with just a few extra third-party extensions. The particular approach that we take is to say that we use the wiki as a graph-based system. Every one of those dots, the container represents the wiki database, and the dots in there represent pages. And the lines that connect all of the dots represent the data that we have encoded right into the pages that links particular pieces of data in one page to other pages. Building this big knowledge graph that we've talked about at length at the Semantic MediaWiki conferences. This allows us to turn MediaWiki into a graph-based database application platform with a form-driven front end and page editor. And I'll draw attention to the fact that it's form-driven front end because we don't want, in the wiki community, most people know that there's this thing called the blank page problem. You go to an organization, you set up a wiki and it's empty and you say, have fun, make your pages. People are not, within organizations, people are not good at developing pages that are structure filled and feature rich. So what we do is we use templates. We use the page forms extension to create standardized ways of collecting data from our different processes. And once they hit save, the data that we collect from those forms is then rendered or presented through standardized templates. And what that means is that if you visit one of the pages in our wiki, you won't get a page with the visual editor. We don't want our users doing visual editor. We don't want our users source editing. We want them editing with form. So they visit the page and the form opens up based on the category of the page, and they can fill it out just like they would any other form, you know, within the government loves its forms. And so we process driven and we develop our forms, we train on our forms, people fill them out, they hit save, and all that information becomes data in the knowledge graph. And then the last bit of this is that once we have built that form front-end graph database, we now have the ability to implement our ISO business processes so that we can basically include the logic into the forms and the templates that kind of carries the user experience from the beginning of the process to the end. So they're doing what they need to do in order to perform their duties. And at the end of the day, there is no stage where the artifacts have to be put somewhere for archive. The data is created where it belongs, it's utilized, it's operationally utilized in place, and when they're done with it, it becomes data at rest for the organization, and we have everything in one place, and we're not trying to do a knowledge management activity at the end of the process. So all the evidence that we're following our processes is contained within MediaWiki Plus. Our auditors come in and we can show them exactly what our processes are, and the evidence that we're following it's all self-contained within MediaWiki. So to put a little bit of a specific example, I would like to walk through the ontology of a NASA risk model. There's basically 4 different classes, and if you're not familiar with classes, classes are a feature that is provided by page forms, and it's really just a clever way of conveniently allowing you to make categories, forms, and templates work as a set. Okay, so if you have page forms loaded in your wiki and you go to the special pages, there's an option for creating a class. You can choose the category, the form, and the template. For the sake of sanity, we always use the same verbiage for all 3. So we could create a category called organization, a form called organization, and a template called organization. And we collect things. This is not an exhaustive list, but we want to know what is the name of the organization and who's their parent. And why do we care about this? Because this very simple construct allows us to allow users to create organizational pages and locate them in a hierarchy. So now we can begin to model within the MediaWiki environment our entire organizational structure and the organizational structure of our partners. And so this is the first of the 4 classes, the organization tool. The second class is the idea of a risk statement. Now, risk is going to get broken into 2 different classes. There's the statement of the risk, which is defined as a condition, departure, asset, and consequence. And for the purposes of brevity, all I'm going to say is that the risk statement is not trying to solve the problem. The purpose of the risk statement is to define the problem. Okay, and you can see that in some of these, like the owner of the risk is a property that points to an organization. So we already have our linkage. I just got done saying that the risk statement is not about solving, it's about describing. So now that we've described the risk, we can create a third class, which is the risk response. And again, notice that we're creating categories for each, forms for each, and templates for each. So each of these represents a collection of pages. And so lastly, we round it out with actions. And everybody's familiar in the business world with the idea of actions. We want things to be actionable. And so the response is basically the high-level strategy of what we're going to try to do, whether or not we think it's a big problem or a small problem, an urgent problem, or something we got to take care of later. And then at the end of the day, the risk response includes some number of actions that get done. Now, these are the 4. So let me walk you through a real-world example. So this is my attempt to create a knowledge graph. If you guys haven't seen it, the purple nodes represent different organizations, and the links between them represent the data that they contain and the orientation in which it points. So, for example, we have the Armstrong Test Facility is at the bottom here, and its parent is the Glenn Research Center, and Glenn's parent is headquarters. Okay, but we're not the only siblings, or we're not the only children in the family. There's headquarters is also responsible for a human spaceflight mission directorate, and what they're doing is running the Artemis program, which is America's current human spaceflight program. And then you have other organizations like the Rocket Propulsion Test Office, and their job is to supervise the agency's capabilities and make sure that NASA retains and they're managing the agency's ability to fulfill the project needs of other mission projects like Artemis. So this is just an organizational structure. And so from these pages, you can basically think of them like wiki articles, and you can say, oh, I'm at the GRC level, and if I'm reading that article, I can say, okay, well, I can see that it manages something called Armstrong Test Facility, and it's beholden to something called headquarters. Now, at the Armstrong Test Facility level, we have our continuous risk management process, and we can use a form-driven front end, click on a link, and we can capture a risk. Now remember, the risk, all that's doing is it's capturing the condition, the statement of the problem, not the solution. And a risk might actually have multiple stakeholders, because this goes back to document and communicate. So immediately what we do after we've created the risk is we separately create the risk response. There are 2 separate pages. And it's important that you don't conflate the risk response data with the risk statement data, because what we want to be able to do is allow other stakeholders to respond independently. And so by uncoupling the statement of the risk from the risk responses, every organization can have their own response to the same risk. And then you can roll up all the responses and look at it together. So for example, the RPT might be a stakeholder in our risk. The Artemis program might be a stakeholder in our risk. And so you start to see that the knowledge graph begins to flush out really fast. And this is a very simple diagram. Lastly, we add actions. And so at some point, because we have documented our risk and we've communicated the risk, and we have multiple stakeholders responding and analyzing that risk, some of the people have decided to watch. That basically means thank you very much. Let us know how that goes. And other people might say, well, hey, look, this is a real problem. I've got to escalate this above my head. And then you also have people who say, we've got the funding, this is our responsibility, we're going to mitigate this. So we come back to this. And I've just given you the whole ISO electronic form-driven electronic workflow database system. We've gone through the ontology example. So we're back here to our continuous risk management policy or process. And so we've developed an in-house policy and procedure for doing this. We take the agency's CRM process, combine it with MediaWiki Plus, implement our ISO electronic workflows, and all of our data is contained in the MediaWiki database. I'm going to skim over. These are just some high-level examples of what the actual forms look like. On the far right-hand side, I'm showing a zoomed-out view of what the form looks like, and then I've kind of zoomed in to show you what that top block is, where we're capturing the risk title and some other preliminary information. So I can say my risk is my wiki server is running MediaWiki 1.31, okay, and the effective requirements are that the NASA network requires supported software. They don't like unsupported software, so we have to upgrade. We could say, and I'm going to skip over all this, but this is the task of trying to define at the organizational level what the risk statement is, what the impact is. And then we have another process for validating and analyzing, and that's done by every stakeholder organization. This is an example on the far right. Again, we've zoomed out and we're looking at the total risk response form. It's a summary of what the risk is. We have a likelihood ranking system where we have a 1 through 5 ranking for very likely, likely, possible, unlikely, and highly unlikely. It's the 1 through 5 scale for how do we think the bad thing is going to happen. We have a consequence chart, which this is a matrix of consequences. At the bottom, you have cost and schedule. Every project manager knows the concerns of a risk impacting their cost and schedule. The agency has a couple of other categories. At the end of the day, we have to go through these and rank them 1 through 5. And again, we rank them at our level. Our parent organization ranks them, and all of this information can then be aggregated to make what's called a risk-informed decision. I'm going to skip through some of these charts out of the interest of time, and I'm going to pass through. If we had more time, I was going to go through kind of a detailed walkthrough of what the system actually looks like. We're using the MediaWiki graph extension to show a pie graph of our risk posture, what we're carrying. You can see that the likelihood and the consequence, 5 by 5 makes a cube. We color code that in order to say that things that land in the green are not as bad as the stuff in the yellow, and the stuff in the red definitely needs to be addressed. I've obfuscated some of the data here for the purposes of this talk, and again, this is all data driven. So these tables, it's not like we're hitting the visual editor button and going in and modifying the value of the number in that table. Our users are maintaining the quality of the risk data in the risk responses. They're saving that information as separate pages, and then these pages are just high-level dashboard pages that are mining all of that information out of the semantic MediaWiki database and pulling it all together in what we call a dashboard view. Okay. And I'm going to wrap it up by reminding everyone that it was not my goal to impress you with NASA's risk management process, but simply what I hope you understand is that NASA's risk management process is vital to our approach to mission success. And at Armstrong Test Facility, we are fulfilling that requirement with MediaWiki Plus. And I'm here to tell you that MediaWiki has what it takes to do risk management at NASA for the benefit of all.
We have time for a few questions. If anybody has looks like we have some questions. You might want to repeat the question.
Sure.
Thanks for the talk. I thought it was a great talk. My question is around forms. And I perceive it, please, tell me if I'm wrong or if I'm making assumptions. I perceive forms as inflexible. So if you have to evolve your schema or your ontology, how do you do that if you're using a form-based approach and not a blank page approach?
Yeah, well, it really comes down to being an ontology editor and not a form editor. So the forms are just expressions of the ontology. So not many organizations have people who think about web ontologies as part of what they provide their organization. So there's two short answers, right? One is the good news is that the agency's continuous risk management process has been pretty stable for over 15 years. And so the likelihood, if we're talking about risk, right, the likelihood of the agency radically changing the way that they do risk is low. And that means that our forms and the way that we collect data doesn't really change. Now, I don't know how to explain it really concisely right now, but I have other presentations that talk about the benefit of using the semantic web over traditional database schemas. So if you build a database that is a relational database in a traditional database system, and the schema changes, the database programmers all tear their hair out. Okay, you changed my schema, all the tables, all the key IDs, all of that was designed around that. The beautiful thing about semantic MediaWiki and graph-based systems is that there is no schema. The schema is the schema is the data is the schema. As the data changes, the schema changes. It's a very fluid and flexible system. The forms just have to keep up with whatever the data collection is, and then the relational aspect of it is just part of what the knowledge graph, the transition from a traditional database to a graph-based system dissolves that concern of trying to have technical debt on your implementation. Okay, wow.
Them first.
Okay, Brian.
Yeah, so where were you in your ISO certification journey when you implemented MediaWiki, and what were the auditors' responses and thoughts and feedback about the use of the tool?
So we've been very careful not to, we've basically developed our electronic workflows alongside of, in fact, my management just gave a talk last week, and they said that one of the lessons that we've learned is that it's very hard to make the transition to the wiki way, but when you have both feet in it, it works well. What's a challenge is when you're trying to maintain traditional methods and you're trying to also simultaneously implement something different like the wiki approach. And so when we're in a mixed mode is when we're most at risk. And so my management's lesson learned is to make the transition as quickly and efficiently as you can, and don't spend any time trying to do both. Auditors have highlighted our use of the wiki as a best practice. So in the places where we have had audits and we have shown them our wiki-based workflows, they have commented that we are doing things that are notably best practices. Let's go with Daniel.
First, thanks for a very interesting talk. You talked about the MediaWiki Plus, including semantic MediaWiki, page forms, and the graph extension for display.
And so many more.
So I was wondering if you could touch on what those so many more are, or at least the key ones.
Okay, so semantic MediaWiki is certainly essential. Cargo, I think, is an alternative. Back when we made the decision to do this, Cargo wasn't up to speed, and I think today Cargo and semantic MediaWiki have their pros and cons. But you got to pick one, right? You need some way to store data in pages and query it back out. Flex forms is a big one. That's what allows us to do our business process modeling notation. We basically document and maintain our business processes in the wiki. Yes, sir.
Flex diagrams?
Flex diagrams, yes. We are also looking to use flex forms. We haven't incorporated that yet. Flex forms allows us to, will allow us to do electronic work instructions where we actually have somebody performing the procedure. And one of the things that our ISO processes want for quality control is they want to know who the person was who did the stuff, when they did it, and that it was done without deviation or waiver. And so we have a detailed procedure that we have people doing, and we want them to be able to check the box, check the box, check the box, and flex forms will give us that capability. Flex diagrams allows us to do, to develop and maintain our ISO processes in the wiki as well as BPMN diagrams. Thank you. Did I answer your question, Daniel? Okay, and then.
Yeah, so it sounds like overall MediaWiki is a good fit for this process, which is cool. But I'm curious, are there any areas where your users are frustrated by limitations or behaviors in MediaWiki where people are kind of like, constantly complaining about X or Y?
Their X would be speed. Our biggest challenge is there's so much information that we're handling. We're running up against the limits of MediaWiki's template depth. We're running up against every technical limit that MediaWiki has. Where in many cases we've had to increase those values, and we're also running on a monolithic system architecture. So we've got we don't have any database replication. We're just basically stuffing the whole application stack onto a single server and, and trying to squeeze all the performance out of it. So I would say that the number one struggle that people have is the speed. It's not unusable, but it doesn't keep up with what I think some of the higher end, more,
And when you say speed, you mean like the speed of queries or like having to do like full page refreshes to like submit forms and see?
Yeah, sometimes it takes good 7 to 10 seconds for a page to load. Yeah.
And I want to add real quick before anyone gets the wrong idea of MediaWiki. These are solvable problems. Wikipedia is the largest MediaWiki instance on Earth, the largest wiki on Earth, and it is running very efficiently thanks to the wonderful work of all the geniuses of the Wikimedia Foundation. And Confluence is also, if you look at Classic, I'm sure you would know that it's just a piece of junk. So I don't want anyone to get the wrong idea that MediaWiki is unusable. It is very usable, and I know firsthand the amount of dedication that Rich and his team are working on to make speed no longer an issue, or at least to mitigate it.
Yes. Thank you very much, Jeff. And in order to further confirm what Jeff was saying is we shoot ourselves in the foot, right? So everything that in MediaWiki documentation says, be careful, that this is an expensive function. Just pour it on. So we have a strategy though, we want to get to Lua. So we have developed everything that we've done using traditional template and parser functions. And everyone has said, yeah, as soon as you move to Lua, you'll gain at least, you'll gain a significant speed increase. We solved that, and I think there won't be any complaints other than that it is not what they're used to, right? So you just, what can you do with that, right? So there is a cultural change, but what we have found is that what we don't want is people using we don't want people using the wiki for one and only one process. Our strategy is to digitally transform every process that we have into one wiki platform environment. And so then if you're doing document control, you're exposed to the wiki. If you're doing risk management, you're exposed to the wiki. And then you get, once you have that one activity that pulls you in and you kind of make your peace with it, then all the other ways that we can use the wiki just start to be, it becomes consistent. And so the goal is to find one workflow that is important to at least everybody in the organization, just to give them that one reason to acquaint themselves with it. And once you get over that, then adoption almost happens overnight.